Hello, welcome back. In this class, we are studying the response of the underdamped system. In the last class, we have seen that damped free vibration. We have derived the equation of motion for the damped free vibration system, that is mx double dot plus cx dot plus kx equal to 0. Where mx double dot it is the accelerating force, cx dot damping force, kx is the spring force. We assume the displacement function, exponential function. As the damping system, the displacement goes on decreasing with respect to time. Okay, if the displacement function, if it is exponential function, substituting this function into the equation of motion, that is mx double dot plus cx dot plus kx equal to 0, we got the roots, that is s1 to minus c by 2m plus or minus square root of c by 2m whole square minus k by m. We have discussed in the last class, where c is the coefficient, damping coefficient, m is the mass, k is the string stiffness. The solution of this equation, it depends upon whether it is a positive value, negative value or 0. It depends upon this value. If c by 2m whole square, if it is more than k by m, then it is overdamped system. If it is less than k by m, then it is underdamped system. If it is equal, then it is called as the critical damped system. In the critical damped system, c value is equal to cc. Okay, now the same thing, the same roots, it is expressed in terms of damping ratio. What is zeta here? It is the ratio of actual damping coefficient to the critical damping coefficient. Okay, you can see the last video, it is explained in detail. The roots, it is in terms of damping ratio here. Okay, the most general solution for the equation of motion, that is x is equal to a1 e raised to s1t plus a2 e raised to s2t, where s1 and s2 are the roots. It is derived here. Okay, you can see the how the in the last video how these roots have come. Okay. In the last video, I also posted the response of the overdamped system. Now we will see what is the response for the underdamped system. What do you mean by underdamped system? Underdamped system where the root, where zeta value is less than 1 or c value is less than critical damping coefficient, c value is less than cc. The roots are, for the underdamped case, the roots are imaginary and it is complex quantity. What do you mean by imaginary? You will see square root of minus 1 I value here. Okay, what are the roots for the damped system? That is s1 minus zeta plus square root of zeta square minus 1 into omega n. S2 is minus zeta minus square root of zeta square minus 1 omega n. You have seen in this, you have seen in the last video itself. S1, S2, it is derived here. Okay, these are the roots for the damped system. Now, if zeta value is less than 1, then this square root of zeta square minus 1, it will come in the negative. It will be negative value. For example, if you take zeta value 0.6, then 0.6 zeta value is, if it is less than 1, then for example 0.6 square, it is 0.36 minus 1, it is minus 0.64. Okay, if you take this minus, outside, then it is square root of minus 1. Square root of minus 1, it is nothing but I. It is a imaginary value. Okay, so it is expressed, the roots for the underdamped system, if it is expressed in terms of imaginary, then the I will come here and this square root of zeta square minus 1, it will interchange its position. So s1 will be minus zeta plus I square root of 1 minus zeta square into omega n. You can see here s1 is equal to minus zeta plus I square root of 1 minus zeta square. See here, this 0.6 square minus 1, it is nothing but minus 6.4. Okay, anyhow this minus is taken outside, minus 1, it is nothing but I here. So what is 0.64? 0.64, it is nothing but square root of 1 minus zeta square. It is a positive value. Okay, so s1, it is plus I square root of 1 minus zeta square, s2 is minus I square root of 1 minus theta square omega n. Okay, now you come to the general solution. X is equal to a1 e raised to s1t plus a2 e raised to s2t. You substitute the value of s1 and s2 here. Okay, for the underdamped case it is expressed in terms of imaginary value. In both these terms we have e raised to minus theta omega nt. This omega nt is common for both these terms. This omega nt is common for both these terms. So you take e raised to minus theta omega nt. Here also same values are there. Minus e raised to minus theta omega nt. Taking this outside. Okay, e raised to minus theta omega nt. It is taken outside here. So it is a1 e raised to this minus theta, it is taken outside, minus theta omega nt. So I square root of 1 minus theta square omega nt. Here also this minus theta is taken outside. So it is a2 e raised to minus I square root of 1 minus theta square omega nt. By Euler's theorem, he says that exponential function, it can be defined in terms of trigonometric functions. E raised to I, the coefficient of imaginary term, that is theta here, the coefficient of imaginary value, that is theta, it can be expressed in terms of a trigonometric function cos theta plus I sin theta. Similarly, if it is negative value, if the imaginary value, the coefficient of imaginary value, if it is negative, then it can be expressed as cos theta minus I sin theta. Okay, the same it is applied for this value here. Okay, e raised to minus theta omega n, this term it is taken same. Then a1, the same a1 is here. What is the, this is exponential function. What is the coefficient of I here? It is theta. Here the coefficient of I is square root of 1 minus theta square omega nt. Okay, the coefficient of I, it is theta here. Here the coefficient, okay, this all coefficient, it is theta. This, okay, cos theta plus I sin theta. Okay, it is expressed in this fashion, cos theta plus I sin theta. Similarly, e raised to minus I theta, it is minus. If it is minus, then cos theta minus I sin theta. It is expressed in this fashion, cos theta minus I sin theta. Then here we have two cos terms. Okay, so the coefficient of this cos function, it is, the coefficient of cos is a1 here, here it is a2. So coefficient of cos is a1 plus a2. Similarly, the coefficient of sine, here it is a1i and here it is a2i. So it is a1i minus a2i, a1i minus a2i. Okay, let us assume this a1 plus a2 as c1 and this a1 minus a2 into I as the c2. Okay, in order to define this response is displacement in terms of trigonometric function, let us assume, already cos function is there, let us assume this c1 as the sine value. So c1 is equal to x sine phi. Okay, let us assume the coefficient of this sine, okay, that is c2, let us express in terms of cos. So it is x cos phi, it is x sin phi cos omega dt plus x cos phi sin omega dt. Okay, and this frequency omega n, it is for damped system, let us consider this as omega d. Omega d is equal to square root of 1 minus theta square omega nt. So omega d, it is the function of zeta and omega n. Okay, substituting the values of c1 is x sin phi, c2 is x cos phi in this. So it can be expressed as e raised to minus theta omega nt. So here sine cos function is a cos sin phi. It can be expressed as the sine function, sine a plus b form. Okay, it is elaborated form. So this is the response for the underdamped system. Okay, where x is the amplitude, it can be determined by the c1 c2. C1 c2 it can be in turn determined by the a1 a2. Okay, by the initial conditions. This is the response for the underdamped system. Okay. Thank you.